Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3. So, for this video, we would like to present our project title, which is Design, Fabricate, and Testing Composite Material Plates. So, this is my group members. The first one, Nur dan Shaidina. Second, me, Nur Atira. Third, Nurul Ashikin. Fourth, Nur Izati. And fifth, Nur Shahida. And the last one is Yusuf Muhammad Idris.
Hello, my name is Mohammed Idris Yusuf. I'm from Group 3 and I'm gonna start talking about our part. And laminate plate theory focuses on laminated composite plates with numerous layers of fabrics and matrices in specified orientations. Laminates have different material characteristics and fabric orientations. LPT analysis and have different material characteristics and fabric orientations. Optimizes composite plates designs to satisfy performance criteria by considering laminate intersections. Composite plate design involves choosing material, defining and laminate, attacking sequence, and assessing structural performance under various loading circumstances. Young modulus is the linear elastic component. The tensile and the elastic modulus or transaction modulus is measured in PA in pressure unit at its 10 pressure unit is compared to 1 kg. It also measures stiff or solid materials elasticity, which is the power needed to break them. And tensile strength material is the maximum stress, and the plasticity rupture period is here. Understanding resistance and flexibility is crucial. A higher Young module indicates higher stress, lower strain, or both. Material stiffness with increasing juvenile bronze rubber, which bends more elastically than steel or diamond, is less stiff. Thank you.
Hi and Assalamualaikum. My name is Nur Izati binti Ismail and my message number is CF22175. Okay, choice of material. The selection of materials before the production of specimen is one of the factors that need to be emphasized during the selection of materials. For example, such as material characteristics, durability, thickness, safety, and user comfort. This project has used a composite plate fabricated which combines two or more materials with different properties to produce a final specimen that exhibits enhanced mechanical, thermal, or electrical characteristics. The material is first aluminium sheet. Aluminium sheet is used as one of the outer layers as a core material sandwiched between other layers. The advantage of aluminium are its lightweight, high strength to weight ratio, and resistant to corrosion. The resulting can profit from these qualities and possibly achieve a balance of strength, durability, and weight reduction. The aluminium sheet in a composite plate contributes to the overall structural integrity, weight and thickness reduction, and performance capabilities to the final specimen, and making it suitable for various circumstances. Second is aluminium foil. Aluminium foil is often utilized as a reinforcement or barrier layer within the composite structure. It also gives the composite material more strength, stiffness, and other required attributes. Aluminium foil to improve the mechanical properties of the composite such as enhancing its tensile strength or impact resistance. Last is tissue paper rolls. Tissue paper rolls in composite plate fabrication refer to the use of tissue paper as a reinforcement material in the manufacturing of composite plates. Due to the lightweight and high tensile strength, tissue paper rolls, which are primarily formed of cellulose fibers and can be utilized as a reinforcement material in the construction of composite plates. Tissue paper rolls increase the composite plate's overall toughness and impact resistance while also adding to its strength and stiffness. They can be used to create lightweight components with improved mechanical properties such as increased strength to weight and resistant strength to weight ratio and resistant to fatigue.
Hi and Assalamualaikum. My name is Nurul Ashimin Zakaria and my matrix number is CF220215. So for the next slide, I will talk about the concept of composite plate fabricated. So The idea of composite material plies mechanics, specifically the classical laminate plate theory, which is LPT, are used in the design and production of composite plates. So, according to the classical laminate plate theory, the composite plate is formed from multiple thin layers or plies, each of which is composed of indirectional fibers and embedded in a matrix material. So these plies are stacked in various orientations to form a laminate structure. So the following fundamental concept and justification are used in the fabrication of composite plates using CLPT is firstly lamina properties, which is the mechanical qualities of each individual plate or lamina in the composite plate, such as stiffness and strength, are defined. And secondly, it is laminate stacking sequence. So the stacking sequence describe how individual plies in a composite laminate are arranged. And thirdly, it is laminate stiffness and compliance. So the stiffness and compliance matrices are used to describe the composite laminate's mechanical response. And fourthly, it is stress and strain analysis. So the classical laminate plate theory calculates stresses and strains within a composite plate under various loading conditions. And lastly, it is failure criteria. So failure, matrix cracking, delamination, and interfacial debonding are all possible failure modes for composite plate. So engineers and designers can construct composite plate with specific mechanical properties and predict their behavior under a very stress condition by applying the classical laminated plate theory concept and justification. So this allow for the development of lightweight, high strength structure in the industries such as in the civil engineering uh, field. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Danisha Irdina binti Umar Haizal. My matrix number is CF220203. I will explain about the strength analysis. The test is carried out on a universal testing machine (UTM). The load cell measures the force exerted on the sum sample, and the strain gauge measures the change in length of the sample. Tensile test results can be used to compare different materials. And lastly, tensile test results are usually plotted as a stress strain curve, and also with a stress on the y-axis and stress on the x-axis. We have three specimens, and these three specimens have different layer, which is the first specimen we got aluminum foil, and then we lay by aluminum sheet, and lastly at the middle of this two layer is sandpaper. And for the specimen 2, the front of the specimen is aluminum sheet, and then aluminum foil, and then sandpaper. For the specimen 3, for the first layer is sandpaper, and then we glue with the aluminum foil and aluminum sheet. The formula that we use to find the E is E equal to stress over strain. For the specimen 1, we got 1.405 megapascal, and the ultimate strength is 81 megapascal. As for the specimen 2, E, we got 1.6463 megapascal, and the ultimate strength is 99 megapascal. And the lastly is specimen 3, only get E equal to 0.7753 megapascal, and the ultimate strength is 39 megapascal. This is because our layer of this specimen maybe have some defect on the paper for the first layer. Thank you.
My name is Fatin Binti Farid, making number CF220213, so I will explain about data collection. Okay, there are three types of specimen: specimen 1, specimen 2, and specimen 3. For initial length, all the specimens got the same length, which is 100 millimeter. After elongation, there are some increases for the length and the final length. Initial length multiplied by after elongation. So for specimen 1, we got 250 millimeter, and specimen 2 220 millimeter, and specimen 3 is 202 millimeter. For the area, all the specimen got the same area, which is 2000 millimeter square. Okay, for the force we got from the result analysis from the document. So as you can see, specimen 2 got the highest, which is 3.951 to 1 kilonewton. Okay, for the stress, to get the stress we have to calculate. So the value for specimen 1 is 1.6156 megapascal, for specimen 2 1.9756 megapascal, and for specimen 3 0.7908 megapascal. So as you can see, stress for specimen 3 is very low than others, and for strength, for specimen 1, 1.15, and for specimen 2, 1.20, and for specimen 3 is 1.02. Okay. Next, Young modulus. So we have to calculate stress divide by strain. So for specimen 1, we got 1.405 megapascal, and for specimen 2, 1.6463 megapascal, and for specimen 3 is 0.7753 megapascal. For average Young modulus for 3 sample, we have to total up the Young modulus for 3 specimen and divide it by 3. So we got 1.274 gigapascal.
Assalamualaikum. My name is Nur Shahida binti Muhammad Yusof. My metric number is CF220219. So the conclusion for this project is project complete success. So our 3 sample use a different types of material for the out layer. So the first sample we use the outside layer is using aluminum sheet. Second sample using aluminum foil, and the last sample we use tissue paper roll. Even the material and interlayer are the same for the specimen 1, 2, and 3. Their strength coefficient are different. The tensile strength of the composite material are 81 MPa, 99 MPa, and 39 MPa. Cast material have a propensity for being brittle, and if the interlayer is not applied properly, it has a higher likelihood of being so as well. This is due to the length of the time that composite material need to join layer by layer. And lastly, composite material are very useful in many areas of modern life, particularly in the field of development. Thank you.
That's all. Thank you.